Ever imagine, like, printing your own computer chips right from your desktop? I know, it sounds pretty sci-fi, right?
Yeah, straight out of a movie.
Well, we're diving deep into a world where that sci-fi might just become reality. We're talking 3D printed carbon nanotube chips.
3D printed chips. Wild.
We've got some research notes here on the latest advancements and the challenges.
Definitely a lot to unpack there, I bet.
Absolutely. So get ready for a glimpse into the future of electronics.
I'm ready. Let's jump in.
Okay, so, we talk a lot about silicon in electronics, and obviously you know all about the limitations of silicon.
Oh, yeah, very familiar with those. Hitting those walls all the time.
Right, right. But what if I told you there's this material out there, it's 100 times stronger than steel
Stronger than steel. Okay, that's impressive.
at 1/6 the weight.
Okay, even more impressive.
And to top it off, it can carry 1,000 times more current than copper.
Wow. Okay, you've got my attention. What is this wonder material?
Carbon nanotubes.
CNTs. Yeah, I've heard of them. A lot of potential there.
And that's exactly what we're diving into, the world of 3D printed CNT chips, where this, revolutionary material meets cutting-edge manufacturing.
Yeah, that's a powerful combination. Definitely a game changer if it all works out.
Exactly. The future of electronics is getting a serious upgrade. So, it's not just like some theoretical material.
No,
Really.
not at all. Carbon nanotubes are already finding their way into some products. You see them popping up here and there.
Okay, so they're out there, but not like widespread.
Right. But think about this. What if we could harness their full potential? Like, imagine printing custom chips on demand.
Like, whoa. So you're saying we're talking about printing chips at home, like just printing documents.
Potentially,
Yeah.
yes. But I mean, let's be realistic. We're not quite there yet. 3D printing CNT chips is still very much in its early stages.
Right, right. Still early days.
But the concept is definitely sound. We've seen some basic components printed successfully, things like sensors and transistors.
Okay, so proof of concept is there. That's encouraging.
Oh, absolutely. But scaling this up to complex high-performance chips, that's where the real hurdles lie.
The research notes, actually, they mention the ink used in the printing process.
The ink, huh?
Yeah. And I'm gathering it's not your average printer cartridge.
No, no, definitely not. It's much more complex. Creating the right ink for this is a real balancing act.
In what way?
Well, for starters, you need a high concentration of pure carbon nanotubes, and they need to be evenly dispersed throughout the ink.
I see. So it's not just like chucking some nanotubes in a solution and hoping for the best.
No, no, no. It's got to be precise. Plus, it has to flow perfectly during the printing process and then maintain its properties after it's been deposited. It's a lot to ask from a material.
It really sounds like it. And on top of that, we're talking about printing it at an incredibly small scale, right?
Absolutely. The resolution needed to print these chips, it's mind-boggling. We're talking features on the nanoscale.
Yeah. And then on top of that, you've got the whole issue of, well, getting those nanotubes lined up properly.
Ah, yes. CNT alignment. That's a big one. It's crucial for performance. Imagine trying to herd electrons through, like, a tangled mess of nanotubes.
It'd be chaos.
Complete chaos. It just wouldn't work efficiently. We need those nanotubes pointing in the right direction, to create those super efficient pathways for electrons to flow. That's how you get the amazing properties we talked about earlier.
So we've got the ink formulation, printing resolution, and CNT alignment, all intertwined, all incredibly complex. It sounds like even if they solve one challenge, it could make another one harder.
You got it. It's this intricate dance. But, and this is the thing, that's what makes this field so exciting. There's so much to figure out, so many avenues to explore.
Yeah, I can see how that would be appealing.
Mhm.
So what are researchers focusing on right now?
Well, a lot of energy is going into developing new types of CNT inks, inks with improved conductivity and printability.
Making them easier to work with, basically.
Exactly. And on the printing side, researchers are pushing the boundaries of 3D printing techniques, trying to achieve better resolution, better alignment. It's a rapidly evolving area. It's really amazing to watch.
It is. It really is. But okay, let's step back for a second. What about the practical side of things? When can we expect to see this tech become, well, less sci-fi and more reality?
That's the million-dollar question, isn't it? And honestly, it's tough to say for sure. The progress is undeniable, that's for sure. But the costs are still high, and there are still some very significant technical hurdles to overcome.
So we're not all going to be printing supercomputers at home anytime soon.
Probably not, no, not in the immediate future.
But the possibilities down the line, they're pretty exciting.
Absolutely, think about it. Imagine, like, printing flexible sensors directly onto prosthetic limbs.
Wow, yeah. Or like custom biochips, for personalized medicine.
Exactly. The potential applications are vast,
Yeah.
and we've only just scratched the surface.
You know, it's funny, we often think of electronics as these cold metallic things, but here we are talking about printing them with ink. It really changes how you think about these devices, you know.
It does, doesn't it? It kind of blurs the lines. And as this technology evolves, it raises some really interesting questions, like how might it change our relationship with electronics if we could design and print them ourselves?
Whoa, that's a big question.
It is. It's something to really ponder as we continue to explore this fascinating field.
So much to think about. This has been an incredible deep dive into the future of electronics.
We're just at the beginning, that's for sure.
Yeah, and it seems like we're in for a wild ride. Thanks for breaking it all down.
Happy to do it.
Always a pleasure.
Likewise.